Hey everyone, welcome to our next iteration of the Quick unPAC series. This month we'll be talking about university facilities. I've got Aaron Levy with me again, one of our regional sales managers with Q-PAC. He will be your one-stop shop, as we called him last time, for all things Q-PAC, especially as it relates to university facilities. So before we get started, we do this every time, but we're going to start with a few announcements. We have the Q-PAC Summit, our Impact Summit, which is October 18th and 19th. In Elkton, Florida at our facilities near St. Augustine. We would love to have you. This is a great event for customers, for mechanical contractors, for manufacturer reps, anybody that has anything to do with HVAC and is interested in what we're doing with ECM fans and EC fan array technology. So we'll remind you all at the end of the broadcast about that. And I will turn things over to Aaron, and we'll jump right into university facilities.
All right. Well, good morning and good afternoon to everyone. Today, we're going to be focusing basically on universities, and if anybody was with us last month for the unPAC series where we did hospitals, a lot of this is very similar, but we're going to gear it more to some of the topics that universities have to deal with and some of the challenges they get. Now, I went ahead and named it Making the Grade to give you some kind of educational nonsense. So we're going to talk about application demands. Starting off, this is just a snapshot of just some of the universities that we've worked with and done applications on. Everywhere from Florida to Texas. We've done some in California all the way up to New York. But these are some main ones that most people would know or probably heard of. And one of the things that the university demands happen is they typically have just expansive campuses, depending on how old the campus is, depending on how what they're studying is. They may have multiple campuses across a certain area, and their static pressures can range anywhere from light duty 1.5-inch stuff all the way to 7+, where you're talking about chem labs and talking medical facilities like we did last month. So it can run the gambit. And those provide a variety of challenges, not just from the maintenance side of it, but also for having to do any kind of retrofit systems later, because a lot of these buildings are really old. They've been built around all the mechanical spaces were kind of built into the building, very much like some hospitals, but a lot of these campus buildings could be significantly older because some of these established colleges are 100+ years old. So while they're building constantly new buildings, you're still retrofitting a lot of old buildings and maintaining those and bringing those up to the modern era. And a lot of those places can maintain student living to cafeteria spaces, laboratories and classrooms. Stadiums and auditoriums do tend to be another big thing as universities spend more and more on their sports programs. They're also spending a lot more money, and the boosters are spending a lot more money on improving the infrastructure, HVAC, and ROI ability to their stadiums, campuses, arenas, auditoriums, things like that, where they're being used quite often and in a lot of ways is a big money draw for the school, as well as administrative and faculty areas as well. So you'll see if you've ever had to step foot on a campus, many people been to college will know just how big some of those places can be. And something we touched about last month is like, where does that maintenance end? A lot of it, is belt driven applications, old double width, double inlet blowers that people are just limping along because that's what's existing. That's where these big air handlers are going to be, and it's just an engineering challenge to get a lot of that stuff back out. So having to grease motors, shafts, belt changes, and changing tension all the time, adjusting pulleys and making motor repairs. And even sometimes some of these larger motors that are 50 to 100 to 200+ horsepower, depending on the application, these things can be anywhere from 1,000 pounds to close to 3,000 pounds. And when you're talking critical facilities, when you're talking chem labs, occupied student areas during, like we are now, I think a lot of students are going back to college right about now. So the woes that they may have not have ignored over the summer may start to rear their ugly heads now that we're kind of in the campus school time frame. And scheduling shutdowns and stuff when you've got thousands of kids going in between campus rooms and buildings is not an easy thing for them to schedule. So they can lose a lot of get a lot of complaints from faculty and administrators and students, as well as just having uh, just cost and labor that of having to do that stuff after hours. So doing retrofit facilities can save them a lot in the long run. And we touched about why we would do a retrofit system for older style buildings, and the biggest one is to add in some some sense of redundancy into their system. A lot of these systems, if a belt goes out or a motor goes out, a pillow block bearing, anything that can knock that system out of place, they don't tend to have backup support. The motor change out could take half a day or longer, depending on the availability of that motor, the time and frame to replace it, get it out, and put a new one back in. Uh, or depending on what component may have failed. So having a sense of redundancy gives the end users and the maintenance crews a little peace of mind that if a fan were to fail, then nobody's panicking. We can add a lot of continuity, which really touch bases on a lot of these campuses looking for sustainability in their ESG programs, environmental, social governance programs. So by having the ability to use one or two or three part numbers over their entire campus, and you're talking in the words of maybe dozens to 100 of air handlers, you really simplify that maintenance division's time of having to keep so many part numbers. Like we saw in that previous picture where they've got hundreds of different belt sizes and having to keep multiples there because some of these bearing or pulleys have anywhere from 2 to 6 belts on them. You really simplify their life, allowing them to do other things outside of the HVAC world when it comes to the maintenance part of their jobs. And then just the downtime of it. With a fan array system with added redundancy built into it, you're not panicking about a lot of downtime. You can schedule that stuff when the students are out of the buildings, or early in the mornings, or in the afternoons, in between lunch hours. There are times to make a quick change out for a fan or any other component that could take anywhere from 10 to 30 minutes. And that risk versus reward situation always comes up. When you're talking about a lot of these systems, you know, they're going to have to replace it anyway. And a lot of those times when they're looking at kicking that can down the road, they can keep limping the system along, limping it along, keep moving it forward. And one of the stories that I remember most fondly is I won't even say the university's name. I've told the story to a lot of people before, but it's a very prominent university in a Western state that the double width, double ended blower threw a blade off. It was a 42-inch blower, an old 60s Champion blower, and the maintenance crew could not find somebody to rebuild it, couldn't find a replacement part handy. So what they did was weld that blade back into place and then completely turn that system back on. And they didn't do it at a reduced capacity. So inevitably, anybody who's listening to the story knows that after about 3 days, it ended up throwing the blade, the weld snapped, threw the blade outside the housing. Thankfully, it was in a concrete room, threw it away from the coil. Thank goodness. It hit the ceiling, took a chunk out of the ceiling, and then snapped the shaft, which was a custom built 5.5-inch shaft. That was going to take anywhere from about 46 weeks to build a new one. And then there was about 30 grand just for the shaft, not even counting all the other stuff they had to rebuild. So these are perfect applications where they're in basements, they're in mezzanines, they're really old. And the risk of having to repair that stuff and keep it going along can create so many other problems that, when you're looking at doing these kind of systems, that retrofits should be on the front burner of those conversations, to add redundancy, to add safety, to add a lot of continuity to a building, not even counting the energy efficiency that they would get when you're talking about doing a large scale system in a university campus build. So outside of lighting and things like that, HVAC is the biggest user of energy. So if you can start to combine some of that stuff in your retrofits to not only lower your maintenance costs, but also to improve your efficiency, there's a lot of benefits for a university with that much conditioned space. And we always say out with the old and in with the new. Even people that are retrofitting or not even doing retrofitting, but buying new equipment will find that you will start seeing more and more EC products in your new OEM equipment. Even makers like Train or Daikin, uh, McQuay, Hakon, they're all starting to switch to them of these, or at least have the option to give you an EC fan solution. So you will start seeing these more and more and more throughout your building, even if you probably didn't request it to begin with. It would just be coming in the new piece of equipment. So being able to move along some of your existing equipment that may not be ready to be completely replaced and switching it to ECs will just add more and more continuity and more efficiency throughout your building. And you could just tell from anybody who's ever to work on the picture on the left, those things are a nightmare. You know, taking off OSHA belt guards and having to reshiv pulleys and grease bearings or take vane axial or the inlet guide vanes off. A lot of that stuff is just a lot of heavy work. And a lot of times I'm hearing that they're finding more and more it's getting harder and harder to find people to work on this stuff as we start getting into the next generation of service techs and technicians. They're not going to be looking at working on some of this stuff. So finding somebody who's skilled enough to be able to work on this stuff is getting difficult, and moving to something that's a little bit more technically sound might be the best option in the grand scheme of things. And then when we talk about how we integrate as a company from Q-PAC into any application, it makes life a lot easier when we're talking about how our system is engineered. It is custom built. You get your bulkhead wall, you get your wiring harnesses, the connection, quick connect box, the main disconnect, the all the screws and zip ties and pressure tubing. Like everything is built into the kit. Short of having the power and communication conduit between the disconnect and the quick connect box or boxes, depending on how many fans are in an array. That's and the mounting hardware for the framing kit. That's about the only thing we don't provide, mainly because, one, we don't know how the distance between the disconnect and the, quick connect box, and we don't know what kind of structure you're mounting the frame kit to, be it concrete or steel or anything else like that. So that's the only thing that we ask that a mechanical contractor ever has to provide. Short of that, we provide everything else. And when we talk about the bulkhead wall, it is a custom solution. So we always tell you measure floor to ceiling, wall to wall. We will make a bulkhead wall that will fit into that given space. It won't have anything to do with what you guys have to do on your end. It's literally just build the frame around it, start plugging in the panels, and it should all snap into place if we've taken all our measurements properly. In the past, what I always do say during the budgetary process, pricing or to get like a price to give to a customer, sizing is not as critical. We need to be pretty close to that. But when we're ready to place the order, making sure we have the exact measurements with our short lead times we have right now, being able to have the right measurements at the very beginning of that process when the order is placed is super important, because there's not a lot of time to make any changes down the road. At that point, once a system may come, there may be some trimming that you may have to do or skinning that you may have to do if you made it too short. So making sure those dimensions are proper at the very beginning of the process of the order is extremely important. And then right now, like I said on the bottom of the screen, I believe that's for everyone. Right now, our lead time is about 11 days, which sounds insane. It's really quick. Our team has gotten so good at this system that they can pump these things out relatively quickly. We have, I think, 98% of all of our inventory is in stock. And that little 2% is for like specialty type things like that we don't normally keep in there anyway, that we have to buy, that we add in after the fact. So all the fans, all the controls, and all that stuff we do in-house. So it allows us to have a very quick turnaround. We can configure bulkhead door arrays with a custom door if need be. When we're removing a lot of those old systems with the double width, double inlet blower or vane axials or something like that, sometimes we lose that access to the coil side of the section. By allowing us to be able to add a door to a solution when applicable and when possible, we can do that so that the mechanical contractors still have access to the front of that coil for doing any maintenance or cleaning or anything like that. So we'll throw that under a specials category when we're designing the system, but just understand that's also a potential application that we can do is we provide a door. We can mount these things vertically or horizontally. I'd never say that we could mount them at an angle. It's not ideal. I always have another solution, and our team does as well. When we come to finding really tough places to place fan arrays, there's always a solution somewhere. We just have to kind of work with what given space is, and we will figure that out as we work together. We'll ask a lot of questions to make sure that we provide a solution that fits in the space and works properly. And many solutions provide N+1 right out the gate. Our selection software that we have really kind of gets you close to that already. In a lot of ways, there will be some changes to your system, be it when you do a retrofit, there's probably going to be a pressure drop from removing that old double width double in the blower to a fan array system that's now straight through, less pressure inside the array by cleaning that up. So you'll see some kinds of pressure savings. So sometimes when we're just on the close side of that redundancy number in our submittals, will actually be, once they balance the system, fully redundant. So we provide that as well. All of our wiring harnesses, again, we solve the problem of having somebody come in there and hand wire every solution. We provide the wiring harnesses from the quick connect box all the way to the fan, and all those connections are made by us. They're all plug and play with Molex plugs. They just snap together. It's very user friendly. Doesn't require any electrician side of it. There's no programming that's involved. There's minimal connections to troubleshoot. You can really figure out if there is a problem in a wiring harness. It's normally pretty easy to find that and then replace it if there is one. And of course, once it's all installed, post installation wise, you never have to really remove those wiring harnesses, because all the wiring connections are made at the fan. And every replacement fan will come with that same connection whip that you see in the picture there, with the pressure tubing, the communication port, and the power port.
I have a question from inside, Aaron.
Mm-hmm.
So I'm traveling with the Daikin Roadshow, and I get asked this question often. If a facility decides to stock extra fans to keep on a shelf, do they need to stock extra wire harnesses as well?
No, not particularly. I would never recommend it. I mean, but every fan will be in its dedicated slot, and every wiring harnesses will be made for that dedicated slot. If you were to keep a standard wiring harness, you could, in theory. I also don't always recommend keeping spare fans. It really depends on the application. If it's mission critical, then I would probably say, sure, it'd be worth it. A lot of times when they keep spare fans, they sit in a machine shop somewhere, and then they'll get moved anywhere from, a dozen times in that shop as they're trying to move stuff around, and it could take the potential of getting damaged. The fans have what we call an L10, or a 10% field failure rate, somewhere between 50 and 80,000 hours, which is about 5.5 to 10 years. And that's rated on the bearings. But if those fans don't tend to fail, you've got a spare fan that you have to maintain. You've got to keep it stored in the right temperatures. You have to make sure that the bearings stay lubricated by keeping it cycled or turning it, and making sure it doesn't bind up at some point. So in a lot of ways, I would just say either leave it next to the air handler or in the air handler space if you have to keep a spare fan. But we keep stock at our facility. We have just our maintenance or support department keeps replacement stock on every component. And when it comes to fans, we have 5 to 10 fans of every size on hand. And the way that these systems are designed is that you're not panicking when a fan does fail. You have you have redundancy built into it, where you can order a fan and have it there in a day or two, depending on your location. And this is what we call our quick connect box. It's mounted inside the array right next to the fans. This is what I would call your power and distribution hub for all of your fans for communication and power. This is what connected to the main disconnect outside. At this point, it's got a fuse circuit breaker in there for fan isolation inside there. It also catches a lot of trouble issues for power stuff. So sometimes you'll see fan alarms that come in on your controller. Sometimes it's just a fuse that's popped inside this controller because it was trying to save something from getting to the fan. So it's always probably the first point I would look at if you see something with a fan alarm and you're checking power, is to check and make sure you have all 3 legs. And if you don't, go back to this point and then start troubleshooting from there. But it does make it a lot easier for our pressure transducers in there. There's a PLC in there or PCB in there. All of that brain work is all done, but it's a single point communication that mirrors back to the disconnect. There's a terminal block in there and power, and all of that just runs communicate like it mirrors back to this quick connect box. So it's really just a nice piece of kit that mounts right next to the fans. As pressure transducers, like I said, it's mounted inside there because we take the low point off of the fans and the high point off of the quick connect box here. And then you see our main control panel outside. Again, this conduit is something that we do not provide, mainly because we don't know, again, like how far you're mounting it away from everything. So making a one kind of solution would be very difficult. Also, every city and state has different electrical building codes. So making one whip, a one size fits all whip may work for some places, but not for every place. So we allow the electricians and we make sure that they know their city and electrical codes, so they will provide that communication conduit for power communication. We do provide BACnet MSTP on premium control panels. We are working, I think there's an IP solution in the works. Don't know when that will be live, but most of the time MSTP does cover us for everything that we have. Airflow and power monitoring right there standard on the touchscreen display. This is really mostly all for the premium controller. We have individual fan alarms, so you'll know exactly which fan has failed. You'll also have on both the premium and the basic controller a hand auto and off control. In the event that you lose your 0 to 10 or your BMS goes offline, you have the ability to switch it over to hand mode and control those fans from the local potentiometer. And with the minimum landing points for the field installation for the electrician, it makes his life a lot easier. The fans have a phase corrector, so landing L1, L2, L3 is relatively easy because they don't have to worry about making sure everything's in phase. You don't have to bump start anything to make sure it's going in the right direction. The fans will already clean up that signal going back to the fan, so it makes their connections 1, 2, 3. They don't worry about it. And then they move on. And then their mirrored connections are just mirrored inside the quick connect box. So as long as they connect like to like, everything should go relatively smoothly. But we also have a full team for technical support if need be. And this is kind of what a full system would look like when it's done. You get to see how all the connections are made from the disconnect to the quick connect boxes. In the event that you have multiple quick connect boxes, it's just daisy chained. There'll be 2 terminal blocks inside the disconnect for terminal block, for quick connect box 1 and quick connect box 2. And all your wiring harnesses are already pre-landed for there. So that's why I probably wouldn't keep a spare wiring harness. In the event that you did have to replace one, we could get one relatively quickly. And currently right now, like I said, we have the industry's best warranty at 5 years, parts, no labor. So as long as it's a manufacturer's defect, we'll replace it. And a lot of times we don't tend to ask a lot of questions. If something were to fail in the first year or so, we may ask for that component back. It just depends on the component and what has failed. But a lot of times you tell us a component's failed, we'll send a new part before we start asking questions. So just know that we're there to support that product as fully as we can. And we touched on this earlier about lead times and installation times. This does tend to be the biggest selling point, not just from the redundancy side of it, but when we're looking at lead time when things fail, depending on looking at our competition or any other type application, when you're looking at new pieces of equipment, you're anywhere from 8 to 10 weeks to maybe 20 to 30 weeks when you're looking at a brand new piece of equipment. And that's stuff that when something fails today and they need something tomorrow, that's not really a viable solution. We have the ability to do quick ship applications for 24 hours, 48, and even 1 week, depending on your customer's needs. Obviously, those come at a premium. So please discuss that with us when you have an opportunity that say, hey, something went down, we need it fixed as quickly as possible. What are your build options and what is those costs associated with it? We'll be happy to help you answer those questions. But they are available for, I believe every size fan that we have at the moment because we have everything in stock. But if you just place a standard order, Standard lead time is about 2 weeks. I think they said on the screen 11 days is kind of where we're sitting right now. Doesn't mean you have to take it in 2 weeks. You can schedule it for whenever you need to. If you're waiting to meet a coil delivery or something else, you can always you can schedule it for later. But if you need it as fast as you can, that's kind of the standard lead time that we have at the moment. What we talk about with a lot of our applications is where they fall. And I would say a lot of our systems, most of our systems are 9 fans or less, which for me puts it somewhere around that 45,000, 50,000 CFM range or less, which means you have one quick connect box, one disconnect outside. And it's a very simple array to install. In most cases, it takes anywhere from 2 to 3 people, less than 8 hours to install it after demo is completed. And as a team gets really, really familiar with these things, it does make the system you're installed to does tend to go faster. And you don't have to have the top shelf, highest paid person doing all the installs. You really need one person who's really good at knowing what they're doing. And then really you just need bodies carrying components into a space. We do have some great videos on our YouTube channel. Man, look, they're already on. Look, they're on top of it. All the little stuff at the bottom of the screen. They know what I'm going to say before I do. But great information, not just these unPAC series, but you also have installation videos and training videos, application videos that we have on there, and it's a great tool for learning and seeing how these systems go in. And while I'll take it with a bit of a grain of salt because we can do it in probably an hour for a 6-pack solution. This is what we do every day. And we're also in a very controlled space, but it does give you an idea how fast these systems can go in. So just keep that in mind. What does that say? Oh yeah. And one of the biggest things I like to talk about is, especially it does come up a lot when we're looking at it, is the ROI factor of things, the return on their investment. When they're looking to spend this kind of money on doing retrofit stuff, they want to know what their payback's going to be and that it's going to save them something over the long run. In a lot of ways, you get to see, depending on your city, state, there could be available tax credits for making to get buildings more lean, to be more green, or whatever that may be for your particular city or state. So you need to look that up and make sure that maybe we would qualify for something like that. But if there's documents we need to provide, please let us know. We'll do our best to make sure that you guys get all the information you need for getting those tax credits for these people and showing energy cost if we need to. This is just an application that we did at University of Florida. They had a 40, a 30, and a 40 horsepower system in there. When we did the retrofits for those solutions, we were able to save them anywhere from that 40% energy cost range. And we were not just giving them like for like, we were giving them an N+1 solution. So to not only give them what they required, but to have an extra fan as a safety buffer allowed them to still keep it under 3 years of energy payback. And that's kind of where they would fall on average. And you see, this is at 5.5 inches of static in that ballpark range, which is, I think is a little on the high side. But yeah, 2.5 to 5.5 times or CF or static pressure range is kind of the bread and butter for these things. So I would normally say a lot of those systems will fall into that 12 to 48 month time frame. And when you're looking at an entire campus of buildings, that stuff just get exponentially better and better and better. And a lot of these numbers just come from an initial standpoint of comparing apples to apples. They give us a set of numbers like, hey, we've got a 50 horsepower motor. This is the wattage we're getting out of it, and this is what we're expecting the system to go back into, and that's what we're comparing. If you really want to get down and dirty for tax credits, they may end up having to do data logging systems of before and after. If you want to do something like a case study with a university, that's something we'd be really interested in as well, is taking a system, putting a data logger system on it, measuring for a while of what they have existing, and then going back in with a Q-PAC system, measuring it after, and being able to really give them exact numbers of what they're looking for to show them just how much it could be. A lot of these systems that we're giving these energy efficiency numbers on, we're doing them on the AC side at a full load. Doing partial loads are very difficult, not knowing what drives on it. all the slip losses and electrical losses that they may find. So it would be very difficult to kind of give them an idea. But if I can give an AC number at full load and give you an EC number, and I'm still basically telling you you're going to get a 3 years based off those numbers. If we're running anything at partial loads or on a VFD where you've got added losses, those numbers could be a lot faster on your payback side. And these are just some other numbers that we had that we talked about last month as well, just to kind of ring true. Is like, depending on the application, that 2.5 to 3 year time frame does tend to fall a lot when you're looking at applications in that 2.5 to 5.5 inches of pressure range. Once we start getting above 7 inches of static, the ROIs do tend to be farther out. At those kinds of conversations, that when we're looking at clean rooms, data centers, HEPA filter rooms, operating rooms, things like that, when we're looking at high pressure systems, the conversation doesn't go more about ROI. It comes more about safety, redundancy, post-installation service, and those applications that will happen for the team that has to deal with it afterwards. So that is, in essence, basically the. I see somebody asking me what building it is in Florida. I don't know. Basically, it was a job that they gave us the information for. I would have to go back and get with the rep to be able to give us that information. It just depends on how they entered it into our systems. I just was able to pull that information out of our software. That was for Scott in the chat.
Yeah, Scott, if you wouldn't mind, you can email the marketing at Q-PAC.com email, and we can stay in touch and we can get you that information. Sorry, we don't have it right on hand. But do we have any other questions right now at the end of the presentation? We'll wait for a couple moments while people think, and we will remind you about the Impact Summit that Q-PAC is hosting October 18th and 19th down at our facility in St. Augustine, Florida. We would love to have you. Like I said, this is going to be an event for manufacturer reps, for mechanical contractors, for facility owners, maintenance teams, facility teams, whoever feel that they are interested in Q-PAC or just learning what the greater technology of ECM fan and fan arrays are going to look like for the future and for future-proofing your facilities. We will be sending out a follow-up survey after this. If you all wouldn't mind responding, it really helps us make these presentations as good as they possibly can be for you and bring you the content that you're interested in. And I believe that's everything. We will host another quick unPAC next month. That will be about just general office buildings and commercial facilities. So that will be the next iteration of our vertical exploration that we're going through right now. We'll wait for a couple more moments to see if anybody else has any questions. If you were not able to attend the entire presentation, or this is a presentation you feel like you want to share with other people in your company, customers, whomever, they will be available on our YouTube page immediately following the presentation. You can find them in the live tab. And then moving forward, we do like to break them down into small micro clips that will also be available in a playlist if there's a particular thing that you're interested in. The longer video will be timestamped, so you'll be able to find the content that directly pertains to you or answers any questions that you're looking for. All right, everybody. Well, thank you so much for joining. Again, if you have any questions, feel free to email the marketing at Q-PAC.com. Even if you think of them later today, tomorrow, we'd be happy to get back to you and answer the questions. Everything will be available on YouTube. And please look for that follow-up survey. Thank you again for attending. We love doing these with you. We hope to see you again in the future. Thanks, everyone.